Hello everyone, this is Miss Thomas and this is your first video in our flipped classroom and it's the intro to algebra. Just as a reminder, the requirements for full credit on our flipped classroom homework are that you record all the notes in your notebook. So basically if I write a note in a video, you should definitely write it in your notebook. And then you need to attempt all the problems posed to you in the video. So not in this particular video, but in most videos, you are going to get a problem that practices exactly what I just go over in the video, and you just need to try that problem. You might get it wrong. It doesn't matter. The key is try to apply what we talk about in the video. So today's video is really just mostly vocabulary that we're going to need to be successful. And so this is the model that we're going to use for a lot of our vocab words. The little circle can be right in the middle of that cross if you want. But we need to know the definitions, characteristics, facts, illustrations, examples, and non-examples. So, a variable. The definition of a variable is a letter or symbol used to present an unknown quantity, to represent an unknown quantity. Characteristics or facts or illustrations. Variables can have more than one value. So you might have an x and the x might be equal to 2, it might be equal to 4, it might be equal to 3,000. So here we have an example with variables in it. And so the variables are typically going to be the letters. Sorry about that. So y is a variable, x is a variable, and n is a variable. The non-examples are any of the constants, any of the numbers and coefficients. So 4 is not a variable, 3 is not a variable, 1 is not a variable. Same thing over here. The 3 and the 4 are not variables. So I know this probably is going quickly. Feel free to hit pause so you can get all this information down and then move on to the next set of words. So an expression is our next vocab word. The definition of expression, it consists of numbers, variables, and operations. Some characteristics, facts, or illustrations. There is not an equal sign in an expression. So that's the biggest thing. Sometimes you guys get asked to write expressions and you put an equal sign because you're so used to writing equations. Those are different things and you have to be careful about that wording, even though it's tricky and they sound so similar. So looking at our examples and non-examples, the example is the 3x plus 4. This is an expression. The non-example is the 3x plus 4 equals 10. It could equal anything, but the reason that it's not an expression is because it has the equal sign. Equal signs are never allowed in an expression. Another vocab word is sequence. A sequence is just a list of numbers. And numbers from a sequence, the characteristics, illustrations, and facts, numbers from a sequence can be made, sorry, the formatting on this got a little messed up, can be made into a table of, I'm just going to cross it off there, values. So the numbers from a sequence can be made into a table of values. So we have this very, very common, very familiar sequence of 2, 4, 6, 8, 10. Generally, sequences can go on forever, so the dot means that it continues. Sorry about that. Continues forever. It's kind of hard to come up with a non-example. We really just need to know the term sequence so that we're all familiar with it in class. But, you know, a non-example would just be something like the number 4. It doesn't have a pattern, it's not continuing in any direction, it's just a standalone number. So consecutive, I'm going to get rid of this little e here, move it over. So the word consecutive comes up a lot in mathematics, and we often don't know what it means. So they're items that follow each other. So these are consecutive people, one right after another. Okay, so in this example, the 2, 4, 6, 8, 10, 2 and 4 are consecutive. Because 2 and 4 are one right after another. I'm going to rewrite the 2, 4, 6, 8, 10 here. Two and 6 are not. And the reason 2 and 6 are not is because 2 and 6 have a 4 between them. So they can't be consecutive because they're not next to each other, whereas the 2 and 4 are consecutive. So any of these pairs over here, 8 and 10 are consecutive, 6 and 8 are consecutive. It's just one right after another is what consecutive means. And our last phrase is common difference. A common difference is the value by which the sequence increases. So if you think about class today, we had that table of values that was going up. It started at 46, then it went to 58, and then it went to 70. And we figured out that the pattern was that it was increasing by 12 each time. Well, that increase by 12 is the common difference. Okay? So the patterns that we were talking about in class today, those are common differences when it's adding or subtracting to move from one term to the next. So if you look at our next sequence, to get from 10 to 13, I'm adding 3. To get from 13 to 16, again, I'm adding 3. And to get from 16 to 19, it's a 3 again. So the common difference here is the 3. Whereas here, we go from 10 to 13, we're adding 3. 13 to 17, we're adding 4. And 17 to 22, we're adding 5. While clearly there is a pattern in what we're adding each time, it's not the same. The fact that it's 3, then 4, then 5, there's no common difference. They don't have anything in common. So that's it. I hope that this was a successful endeavor for you, and I look forward to making some more videos for you. See you in class tomorrow.